So hi, I'm Peter, and today I'm here to talk about a passion of mine, and that is dealing with time in development. And I want to focus on two problems when you think about it, time in particular. And the one is dealing with time from now, and the other one is dealing with time that is based on a calendar event. So maybe let's just go through these, because the first one, machines are really good at dealing with time from now. So when do we need it? It's always when we say like, hey, anything needs to happen 2 seconds from now. Or I'm gonna block that input for 3 seconds. So that is really easy because we can just say, okay, we have a time now, and then in 3 seconds, there's something else happening. It's also in real life use cases. Think about, for example, your friend or coworker. You ask them, hey, are you coming? Are you ready? Yeah, give me a minute. So that is also time from now. Your coworker expresses his intent to go with you like in 1 to 15 minutes, and then he just joins. Time on the calendar, on the other hand, usually goes around an event that is set on the calendar. So for example, Monday, the 25th, also a particular time, and for the best part, for a time zone. And who here had to deal with time zones in development so far? Okay, yeah. So that's the natural enemy of a developer, and it's going to be even more fun in 1 to 2 years in the EU. But yeah, so let's have a look at why these problems matter. First, why does it matter for React? Who here has used or even seen React here in the crowd? Maybe just so that I know. So most of you, otherwise, like this is how you render a very, very basic component. And what you get is you give it an input, like a birthday and the name, and then you render something. So for example, here text, hi, I'm Peter, and I'm a few seconds old. Now there is a problem here. It's a bad practice in React to rely on external context inside a function or even a component inside a render function. And here, this external context masks behind date.now. Because now suddenly it depends on when this function is called to say that you're either 1000 or 2000 seconds old, then you refresh the page and suddenly it changes. But even more importantly, it won't update until you call the function again. So you need to periodically ensure that the render method is called again and that your component updates. This is the problem for React, and now why it matters so much for me, or even more importantly, for us at Order, where I am a founder of. We're a small startup in the team, and what we do is we have a smartphone app so that you can order in restaurants. You go there, you sit at the table, you see the chip on the table, you check in, and then you order, and that usually goes way quicker than asking for the waiter. And at Order, we realized that pretty much every element that we put on the screen has to be presented in the context of time. So just as an example, we saw that, hey, here we need to display the next time slots that we want to allow people to order from their office, like if they want to order to go. But also, all the selection on the menu needs to update based on, is it available, is the kitchen open, is the venue even open, and so on. So what we have to present are a lot of elements, but we don't want to update them all at the same time, because we need to choose the granularity at what to update. So for example, here at the top, these sliders are always 15-minute windows, and we know this. So we don't need to update it every second, or let's say every 16 milliseconds or something else. We just need to update it every 15 minutes, based on the wall clock. So for us, the important events are 10 o'clock, 10:15, and so on. Usually also, if we want to update on a higher granularity, every 5 minutes, every single minute, we also want it to be based on the wall clock. So if we want every 5 minutes, then it shouldn't be at 9:59 and then 30 seconds and 5 minutes from there, but also 10 sharp, 10:05, and so on. Now for these items, we go for a 1-minute granularity because our restaurants can say, hey, this is only available from 11.1, which no one does, they just say 11. But it can happen that some of these minute windows are different. And this is why we decided to tackle that problem with a very small library that we call React Timesync. And in React Timesync, we try to address these problems and one more, which I'll get to in a second. So the first one, the time from now, boils down to a countdown. In the end, you have an event and you calculate the time until you want to show an update, a periodic update. That might be that you say, hey, on Saturday, it's the start of a season, so I want to show a daily timer and then update it daily if the website remains open. It's also if you, for example, want to block an input, like a button, and say, okay, you press the button, and now you can't press it again for 3 seconds. So this goes into the countdown area that covers the time from now use case. The other one, which we use more extensively, is a time component. A time component is there to periodically and infinitely update a set of components or one React component and always passes down the current time. However, there's one twist. The current time is rounded to the interval that you require. So to give an example, if you say you want your time component to update every second, you will receive the current time with rounded to the last second. So it will not include the milliseconds, it will just give you the current second, and then you can work with it. So we don't work with millisecond based time. If you want to update it every 15 seconds, then you will only receive the time rounded to the last 15 milliseconds starting from 1st January 1970. So like based on the calendar again, that is always rounded to the most important events in our time frame. And why is that? Because especially in React, we calculate a lot of output based on inputs. And sometimes when we create new objects, like arrays or just plain JavaScript objects, then components might decide to re-render. So if there are pure components, they might re-render because they don't know any better, that the input has not changed. And to prevent that, we say you can specify the granularity, and then for a certain time frame, let's say our 15-minute window of our input up top, we will always receive the last relevant time for our input. So these two are the main components, and I'll also demo them in a second. And the last one, which I'll not show today, but if you're interested, you can look at the README or just talk to us. Here, this is about using it with Redux. We use Redux extensively, and there it's also important, especially with the use of selectors, that we can get a time that doesn't change until it has to change. So this is why like you can use it with your Redux containers, and then your components don't update that often. All right, so then it's time for some demos. First, I also have to thank my teammate Jait, who made the demos while I was doing the slides, because this is a lightning talk and we're a busy startup, so we just did it 2 hours before. Okay, so let's first have a look at a countdown component. What we see here, I'll actually zoom in. We see some form, so I'll enter something. I hit enter or press login, and then it doesn't update for 3 seconds. So like here, what it does, I press it and then it blocks me. Like this is a common use case that, for example, we use to improve the UX actually of our restaurants. Like it sounds counterintuitive to block input, but for them it helps because they are usually just smashing buttons on some tablet, and if it would react every time, they would print 5 receipts, so they don't want that. So we block pretty much every button. So how does it work? What we have here is like the countdown component. And the countdown component receives one prop that is a millisecond timestamp, UTC based, until when that countdown should run. I could also pass the granularity again, like seconds, minutes, hours, days, and then I will receive a time left in that granularity by default in seconds. And now I know how long this will run. So to disable the button, I just say, hey, there is still time left. I don't want that button to be enabled. And also here, like we use time left and display the time left or the login, depending on what we need. And this is how we can guard components or also display real countdowns if we need to, if you have that use case in your app. And in the end, what this now also does with demo, just to show it, if I click Start Countdown, then we create a millisecond timestamp, that is 3 seconds from now, and pass it to the component, so it will always update and then render itself. If that timestamp is not a full second, it will update exactly as often as it needs to render to be readable by humans. So for example, you will never see that there is 0 seconds left or something, but it will always display in a way that is relevant for humans. As a second demo, I first want to show you why actually timesync was born when you have a lot of timers and then you need a way to synchronize them. Because something that I haven't mentioned yet is that for the time components, all timers are run synchronously. So they are called at the same time, which means that for React and React Native, only once a tree is created and sent over the bridge in the native case, or to the browser to DOM to update. And why that matters, I just want to show you here what happens if you just use a normal set interval. I create a few timers here. So what we see, and this is now only one use case where we have like numbers updating, so it's not too bad, but they are not updating at the same time. And this is also normal user behavior, where, for example, you change a tab, so when you mount components, you have just different timers running, and then you get a mess of an UI, especially if you display different times. So, for example, this has to cook at that time, the current time is this. So then, if you want to display multiple things at once, they should be in sync to provide a better user experience. Maybe to show the example here. So here we have it. I'm not sure why it's that small. Okay. So here we have everything in sync. So no matter when I start the timers, starting with the next second, because our granularity here is seconds, they're all going to be updated in sync. And there will be no flickering, especially like with, for example, colored events. Everything will just update once. If you have multiple timers, so for example on different granularities, then we will update independently. But for example, if you have a 2-second timer and mixed with 1-second timers, they will also just jump in place when they need to be called. So let's look at how this looks like. If we look at the timer itself, so maybe just to start with the index page, what we do is we actually, here, is that the right one? Yeah. So for each timers, we just return it, which are React elements, and at the top, we also display a timed element. By default, the granularity are seconds, and the unit for that is 1 second, because you could also choose to, for example, update every 90 seconds if you want. And what you receive is, again, like you pass down at render props a function which retrieves the current time. That current time is on a Unix timestamp basis, but rounded to the granularity that you need. Here we see it as well, where we have one-time component, and inside we just pass them down, but all are synced on one level. This synchronization is achieved with one provider component, so like it's using the React Context API, so somewhere there needs to be a provider. In this example, I think it's here. In the end, somewhere in your hierarchy, you need to provide a time provider, and you can have, of course, multiple time providers if you need different levels of synchronicity. If you, for example, have to deal with pop-ups or something else that you want to control, then you can use it externally. Okay, almost done. Maybe let's wrap up with use cases and bad cases. So when should you think about using React Time Sync? It's whenever you have to display something in the context of time. And I really want you to think carefully on when that is, because I think it's way more often than we just first think. For example, imagine a website, Deutsche Bahn, you want to order a ticket. Standard form, you're being asked, when do you want that ticket? And that form starts at today or maybe tomorrow. But if you leave that website open because you want to order it at 6 p.m., but then you decide to go home, next day you're gonna wake up your laptop. Now, where is that form?
The session is broken anyway.
That's a different problem. But yeah, no, the form usually, sadly, stays in the old time. So like it does not update, that the current time needs to be updated. You fill out your form, you fill out 5 minutes of information, hit submit and get a bad request. So that doesn't help. So look at your own application and your own use cases and identify this needs to be displayed in the context of time. Maybe do a search all where you access data.now or some moment functions, but be aware that it happens way more often than we would first expect. Use cases also if you want to synchronize timers across an application, which might not always be what you want. Sometimes you want things jumping out of place, that it looks better. It depends on what you want to do. However, if you want to ensure that everything is synced, then you can also use React Time Sync. When not to use it? Don't use it when you need millisecond precision, because we don't offer that. Like, it would not be possible to guarantee millisecond precision that you are getting called exactly on that millisecond that you want. However, we can guarantee that it's within the same second, otherwise you are blocking the event loop and there's something else going wrong. So for example, video games are out of question, but I think like for video games, other approaches are just way better. This has been developed with displaying content for normal user flows where just the calendar time is more interesting. And usually video games don't fall into that. I would also recommend against using it somewhere in the backend, because it depends on how you design your application. So for example, if you have a stateful monolith, then that might be an idea, so that you could go ahead and synchronize your timers across a JavaScript application. However, usually that's not the case. You would then introduce state, and as soon as you have multiple servers running that run the same code, you're anyways out of sync, and your timers don't really work anymore. So usually in the backend, there are way better options for this. Then, lastly, I have another reason why I'm here. We at Order, we are a new startup. Like, we were founded as a GmbH just in April. But we got our first financing round, and now we are trying to grow. The idea is that we really want to find people that are passionate about building user-focused, customer-centric products. And our mission is to become the digital heart of gastronomy and hospitality businesses. And we want you to help us to achieve our vision of making every guest happy. So if you think about moving, if you think about taking next step forward, you want to grow with us, then feel free to talk to me afterwards or just write to me.
Question: should the same sum function? So is it should it really be the same sum function?
Yes, it should be the same sum function.
Really, that's fucked up. Why would you check for the argument? No.
There is no sane reason to do it.
Yeah, there's no.
But it's fine.
Ideally, it should also allow further arguments. So you can write third pair of parents and
when I just query it once, and then it expects me that I call it once after that, or twice, or what. Sometimes that, that's really bad style. Sorry for that. That makes me itch. Sorry for that.
Great talk. Let's have some questions. Be brave. Yes, dark side.
Yeah. What's the point of using timers that map timer arrow timer? Is it different from just timers?
What do you mean by wrapping timers around timers?
Yeah, you had this line on one of the slides when you have timers that map the identity function. When you probably just get the same array.
Yeah, I think I know what you mean. You mean this one, right?
Yeah.
Yeah. In the end, here there is no big difference, but I think that we changed the code from before because we wanted to try something out, and we just copy-pasted it from the other one. But good catch. Any more questions?
Be brave. Last talk, maybe last question.
Yeah.
Oh, okay, I think I skipped the main part. So, is this something I can npm install?
Yeah. It's
Yeah,
just
great.
React time sync. All right, then thanks very much.
Yeah, well, thanks a lot.